All right, day 6, the first part of day 6 here, we're going to talk about complex numbers. And if you remember, complex numbers are just numbers that have a real component and an imaginary component. So like this here, like a plus bi would be a complex number. And you did some of this in Algebra 2 at some point in there. And maybe you plotted them, hopefully you plotted them in Algebra 2, but what we do is to plot these in the complex plane, it is the x-axis. What was the x-axis is now the real number axis, and what was the y-axis is now the imaginary axis. And what we're going to do is when we plot that, then we can find the distance from 0. Well, distance from 0 is the definition of the absolute value. The absolute value sum is how far it is from 0. So we can figure out how far a complex number is from nothing, okay, from 0. So first off, to plot these guys, and we'll get back up to this in a second. I'm just kind of starting it out here. To plot these guys, you can you go basically 1 to the right and then 2 up. So I'm going to go to 1 on the real axis, 2 on the complex axis, and I get that one right here. So that's 1 plus 2i. 3 minus I would be right 3 down 1. So 3 minus I. Negative 2 in the real axis plus 2. So there would be negative 2 plus 2i. And then I itself, that means go left or right, none, because you're not on the real axis at all. You're right here, and you go up 1. So there's where I is. Okay, now the distance from the origin would be its absolute value. So when I say absolute value of this, just think 1 squared plus 2 squared would equal the distance squared. So it's really just the hypotenuse of a right triangle is kind of how we're going to find that distance. So we'll get to some of that towards the back. So plot these guys here. So 2, negative 3. 1, positive 1, just the number 3 would be right there. So number 3. And this was 1 minus 3i. And then negative 2, negative I would be right here. Okay. Now what we're going to do here, towards the bottom, we need to write it in polar form. So and honestly, it's kind of nice that polar form is kind of telling you, in like the way we write it, actually tells you how to find the rectangular form. So they kind of go back and forth, and it basically gives you the directions. So the polar form of a complex number, which this would be in rectangular form, z equals a plus bi, is z equals r, where r is that distance from 0. That's your radius. So the absolute value, and it says right here, so that's what r is. So it'll be r and then cosine theta. Remember, cosine represents your x coordinate. Well, that's the real. So there's no I on that. It's just cosine theta, so that tells you how far over to go. Plus I sine theta. I is on sine because that's up and down. The y-axis is actually now your imaginary axis. So I gets slapped on with sine theta. Okay, so if I'm going to try to, and this would be rectangular form, 3i, I want to put it in polar form. Well, first off, where is that? And if you look, this graph down here is a polar graph laid on top of a rectangular graph. So they're together. The origin's in the middle. So if I want to plot 3i, 1, 2, 3, right there is 3i. So if I want to put it in polar form, I've got to think distance from 0 and what's the angle. Okay, so and z just means you're talking about a complex number. So the letter z just means complex. It's going to equal, and then r is how far it is from 0. Since this is straight up, I don't have to do anything. It's just 3 units away. So it'd be 3. And then I'm going to do cosine plus I sine. And then my angle in this one, I need to do radians. Well, what's the angle here? Well, that would be opened up pi over 2 degrees, or I'm sorry, pi over 2 radian, 90 degrees. So it would be pi over 2. So that's how you would write that in polar form. This guy here, again, this is rectangular, so I'm going to go right 2, up 2. That's right there. So that's 2 plus 2i. And now I want to get the polar form of this, so it's going to equal r. Well, how far from 0 am I here? So it looks like about 1, 2, a little less than 3, but I'm not quite to 3. I'm going to find it by doing, looking at the hypotenuse of this guy. So this was 2, this was 2i. Well, I'm going to do 2 squared. So square root of 2 squared plus 2 squared, because I want right 2 up 2. That would give me radical 8. If I want to leave this in in radical form, 2 radical 2, and then it's going to be cosine plus I sine. And the angle on this, if I want right 2 up 2, those are the same. So that's a 45, 90 triangle. So this is 45 degrees in here. I'm opening up 45 degrees. I need to put that in terms of radians. So it'd be pi over 4 radians. So this would be the polar form of these guys. Okay. Let's go to the back. Oh, and I should point out, if you wanted to convert, well, I'll do this one. If I want to convert back to this, I would take 2 radical 2 times cosine pi over 4. If you put that in your calculator, you get 2. Plus, and if you had 2 radical 2 times sine of pi over 4, you'll also get 2. And then you have your I there. So basically, this is telling you how to find the rectangular form of it. You're just going backwards. So kind of like it has instructions. Yet the answer itself is also the instructions for finding the rectangular form. So write the complex number in standard form. Start by making a rough sketch of the location. I will say on your homework and on the test, we're going to ask you to give these in simplest radical form, not in decimal form. So we don't want you to just type it in the calculator. If you want to check yourself, you can. You can definitely just type it in and check yourself. But so first off, this would be, what this is saying is my radius is 3, so my r is 3. My theta must be 30 degrees. So on here, it looks like these are each, so 15, 30, 45. Yeah, so it's every 15 degrees. I don't only need 30. So this one's going to be on that line out 3. So 1, 2, 3. So it's right there. Now I want to write that in rectangular form. So notice I'm right 1, 2, maybe 2.5-ish, up 1.5-ish. Well, that's not, ish isn't good enough. We need to find the actual numbers. So on this one, I'm actually going to distribute the 3 out. So it'd be 3 cosine 30 minus I. I'm going to put 3i sine 30. Now I need to figure out what is cosine 30 and sine 30. So, and we went in simplest radical form. So if this is 30 degrees, we're just going to do just the sine 30 itself. So I'm going to use the unit circle to get the ratio, and then I'll multiply it by 3. So really it's a 3 radius, but I'm just going to try to find what cosine 30 is by itself. So this would be a half, this would be a radical 3 over 2. So this would be 3 times, and then cosine 30 is adjacent over hypotenuse, so that'd be radical 3 over 2 minus 3i, and then sine 30 is a half. So this would be 3 radical 3 over 2 minus 3 halves I. So that'd be the rectangular form of it, and that's exact. So we don't leave it in exact radical form, simplest radical form. This guy here, when it's written like this, the radius is 5, the theta is pi over 4. So pi over 4 is a 45-degree angle. That's this guy right here, and go out 5 units. So you got 1, 2, 3, 4, 5. So that point right there, now we're trying to figure out how far right and how far up do we go to get there. Okay, so that'd be 5 times cosine pi over 4 plus 5 times I sine pi over 4. Well, pi over 4, that's a 45. So if I just do my unit circle here, pi over 4, that'd be, if this is 1, that'd be radical 2 over 2 and radical 2 over 2. So 5 times, now the cosine of pi over 4 would be the adjacent of the hypotenuse, so radical 2 over 2 plus 5i, and then the sine is opposite over hypotenuse, which would be radical 2 over 2. So this would be 5 radical 2 divided by 2 plus 5 radical 2 over 2i. So that'd be your final answer in rectangular form. Okay? So try to keep it simple. Don't overthink things too much, going from rectangular to polar and polar to rectangular. But let me know if you have any questions.